Good morning, Algebra 2. What is going on? So last week, we started briefly talking about these weird imaginary numbers, which we represent with the letter I. And if you recall, I equals the square root of -1, right? There is no such number that if you multiply it times itself, it equals a -1. Therefore, there's no square root of -1. But we've got this fancy number because there are no real numbers that works for us, so we have this imaginary number that we call I. And the cool thing about I is that when you raise it to higher and higher powers, things change, right? If you multiply an imaginary number times itself, it changes into a real number. And so one of the things you need to do is be able to simplify higher powers of I, because it's only going to turn into one of these 4 special cases. I to the first equals I to the second equals -1, I to the third equals -I, and I to the fourth equals +1. And so this problem here, we have I to the 27th. I know it's going to be one of those 4 possibilities. So how do you figure it out? Well, we do know that since I to the fourth equals a 1, we essentially ignore every multiple of 4 that goes into 27. And so if the exponent is divisible by 4, we would just say the answer equals 1, because you've got a bunch of I to the fourths. Essentially, you've got a bunch of 1s being multiplied together. But in this case, 27 is not divisible by 4. And so we need the biggest number, less than 27, that is divisible by 4. And so we go down by 1. We think, okay, how about 26? No, that's not divisible by 4. Okay, how about 25? No, that doesn't work. All right, how about 24? Oh, wait a minute, that does work, right? I to the 24th is divisible by 4. So we know that we can ignore I to the 24th, because that's just going to be multiplying a bunch of positive 1s together. So we get rid of 24, and how many i's are we left with? So this is where you kind of subtract those off, and you think about, well, what's the remainder? How many do we have left? Well, I'd have 3 i's left over, right? Because if I add those up, 24 plus 3 is 27. Oh my gosh, I just saw my goof over here. This is not I to the second. This is I to the third. Kind of important because that's what we have here, I to the third. All right, so back on the left, I to the 24th, we can just ignore that because that equals a +1. That's the same as saying 1 times 1 times 1 times 1 times 1 times 1 times I to the third. So all we really care about is I to the third. And if we look at our handy dandy chart over here on the right, we see that I to the third equals a -I. So I to the third, we write that as -I. And that's that. So that is I to the 27th simplified. That's going to come into play with our lesson today, because we're not looking at just straight up imaginary numbers, but we're looking at something called complex numbers. Ooh, complex. I hope this isn't a complicated lesson. It's not that complicated, don't worry. So a complex number is used to describe a number that has both a real part to it and an imaginary part to it. We represent this complex number with 2 pieces. So kind of like a binomial, right? There's 2 terms. There's a real part, which we represent with A, and an imaginary part, which we represent with B times I, where I is that imaginary number. Remember, I equals the square root of -1. And so we write our complex number just like this, A plus BI. So an example could be 2 plus 5i. That's a complex number. There's a real part here on the left, a 2, then an imaginary part, which is the 5i. That's really all there is to a complex number. I can't add them up because you can't add a real number with an imaginary number. They're unlike terms. Again, you can think of I almost like a variable. That's the way it kind of behaves, where you can't add an x to a constant, right? They're unlike terms. Same idea here. Now we're going to talk about our basic operations: add, subtract, multiply, divide. And luckily, adding them together is extremely straightforward. You simply add the like parts. It's like combining like terms, which we've been doing for years now, right? Just with non-imaginary numbers. In this case, we would simply add the real parts with other real parts. So in this case, 2 plus 5, which is 7. And then we add imaginary parts with other imaginary parts. So if I have 6i and I subtract one of those i's, I'm left with 5i. So if I add these two complex numbers, we have 2 plus 6i plus 5 minus i, we get this new complex number, 7 plus 5i. Very straightforward. The only ones you really need to be careful about are when you're subtracting them, make sure you distribute that negative. So go ahead, pause the video, take a second, and go ahead and subtract these two and tell me what you get. So whenever I see this negative sign right here, I always think about like distributing it, each of the terms to the right. So I'm going to rewrite this whole expression out. Now the left term stays the same because there's nothing in front of it that I would need to distribute. So that's nothing to worry about. But I'm going to distribute this negative sign to the right. I'm subtracting 3 plus 2i, which really means I'm subtracting the 3 and I'm subtracting the 2i. Now that I've distributed that, I'm just going to go ahead and combine like terms. So I've got 8 minus 3. Those are both my real parts because they don't have an I next to them. And 8 minus 3, that's just 5. Now we've got our imaginary parts, a negative 2i and another negative 2i. Well, if I have negative 2 and I subtract another 2, we get a total of negative 4i. Make sure you include that I to indicate that this is the imaginary term. If you didn't have that I, you'd have 5 minus 4, which equals 1. And that's not the case. That I is essential to keep in there for our final answer. Nice and easy. Multiplying, it's just like multiplying polynomials. All right, same exact thing here. I've got a binomial times a binomial, and we just distribute, right? You take the 4 times each term on the right, then we're going to take the 3i times each term on the right, and there's only one small difference here, and that is simplifying the exponent of I. So remember, when I do distribute this, I'm going to have an I times I when I do that last distribution, and that's going to equal I squared, which is going to change it, right? I have to simplify that exponent. We know I squared equals negative 1. So let's work this one out. First, 4 times 5 is simply going to be 20. Nice and easy. Then I take 4 times negative 6i, and, well, this is being multiplied. So a 4 times negative 6 is just a negative 24, and the I comes along for the ride. Now we have to distribute the 3i. Well, 3i times 5 is just 15i. And now the last part, we've got 3i times negative 6i. So first off, 3 times negative 6 gives us a negative 18. But now I times I, this is super duper important, that's I squared. And so many times students forget to square this last I. They forget, they think I times I, they just put an I along for the ride. And that's not the case. That's going to change things. Because this last term, this negative 18i squared, well, we know that I squared actually equals negative 1. So I'm going to replace I squared with negative 1. And remember, this is being multiplied, right? It was negative 18 times I squared. So this is actually negative 18 times negative 1, which turns this into a plus 18. All right, so if I bring the rest of my terms down, right, this is like our new problem right now. That I squared, essentially all it did, if you want to think of like a shortcut, is whenever I see an I squared, I just cross off the I squared and I flip the sign of the term that's right in front of it, that's connected to it. And so that I squared changes the negative 18 into a positive 18. And then from this point, looking at this problem, we just combine like terms. So I've got a 20 plus 18, well, that simply equals 38. Then I have a negative 24i plus 15i. Well, that's also pretty easy. That's going to equal negative 9i. And at this point, I've got my real part up front, 38, and my imaginary part, the negative 9i, second there. And that's just our answer. So we multiply these complex numbers, you're going to get a single complex number. remember there should be just two terms or less, right? That maybe the real parts cancel out or maybe the imaginary parts cancel out, but you're never going to have more than two terms in your final answer whenever you multiply these, unless you've got additional variables. But if it's just straight up numbers, a real number with an imaginary number, you're always going to be able to simplify it to just these two terms, a plus bi. Oh man, now I've got to go and make things complicated, right? Go ahead and take a minute, pause the video, and multiply these together and see what you get. Now to make this a little bit easier though, I do want to draw your attention to these first two binomials. See if you notice something unique about them. And as a little advice, I'd say multiply these first, get a new number, then go ahead and multiply in that third binomial once you're done. All right, go ahead and unpause the video once you finish. All right, so the reason I called your attention to these first two binomials is hopefully you realize how similar they are. Only difference is one's a plus and one's a negative. And you should remember from last week that that is called a conjugate, right? When it's the same two terms, but one's got a plus in the middle, one's got a minus in the middle. Now the nice thing about multiplying conjugates is if you do distribute everything, right, like foiling it out, those two middle terms will always cancel out. If I do multiply these, we're going to get a negative 6i and a positive 6i and a negative 6i, which cancel out. So whenever I multiply these first two together, I really just have to multiply the first two terms together, 3 times 3, which is 9. And then I have to multiply the last two terms together. So 2i times a negative 2i is negative 4i. Be careful, it's I squared, right? Because you've got an I times I, which is I squared. Now right away, I'm going to say, go ahead and take this I squared into account and simplify it. Now remember that I squared equals negative 1. So what that's essentially going to do is change the sign of this term, because I squared is a negative 1. And so I cross off the I squared and make that negative 4 into a positive 4. So that this first term here from multiplying gives me 9 plus 4. Wait a minute. There's not even an I anymore? 9 plus 4, I can do that. That's just 13. Holy moly. Well, that was easy. So 3 plus 2i times 3 minus 2i just turns into 13. That's pretty cool. But now don't forget, we have to take into account this final binomial. So I'm going to bring this 13 over here times negative 1 plus 4i. And this is actually a pretty easy problem now. I'm just going to distribute the 13 times each of these terms. Well, 13 times negative 1 is negative 13. 13 times 4i, well, 13 times 4 is just 52. So this gives us 52i. And that's it. That's our complex number right there. Negative 13 is our real part, and 52i is our imaginary part. Great job, everyone. Now the last operation. Look at this, almost done. Dividing complex numbers, it's actually going to be just like solving radicals, right? When we did division by radicals, we didn't divide by a root so much as just get rid of the root in the denominator. So for these problems, whenever there's an imaginary number in the denominator, we need to rationalize, there's that word again, rationalize the denominator, which simply means we need to remove that imaginary number from the denominator. And we've got the same kind of rules that we did for rationalizing a radical, meaning it's going to be a different technique we use to cancel out a binomial versus canceling out a monomial with I. Now, if you remember, between the two, the easier one was when you've got a radical binomial on the bottom, because all you need to do to get rid of I is multiply it by the conjugate. And the conjugate is just switching the sign in the middle. So here I've got 2 divided by 3 plus I. The conjugate would simply be 3 minus I, which we multiply on the top and on the bottom. And when we multiply this, keep in mind these are all parentheses. So in the numerator, I would just distribute the 2 to each of those, which is nice and easy. 2 times 3 is 6. 2 times negative I is negative 2I. In the bottom, this isn't as difficult as it seems. Since these are conjugates, remember, like on that previous example, we just have to multiply the first 2 terms together. 3 times 3 is 9. And then multiply the second 2 terms together. So first off, I've got a positive I times a negative I. Well, positive times negative is negative. I times I is I squared. Now we do still have to simplify that denominator because there's still an I down there, but remember it's going to change into a real number. I squared is a negative 1. So I cross this off and I change this sign. Now if there's no number here, if there's no coefficient, remember that that's actually just going to be a 1. So this turns into just simply a 9 plus 1 in the denominator. And so we can write this as 6 minus 2I over, well, 9 plus 1, that's 10. And now look at that fraction. It looks pretty good. There's no more I in the denominator. There is one last simplification step that we could do. Now if I look at all the terms, there are 3 terms here, a 6, negative 2, and a 10. And if you look at every term in a fraction, in the numerator and in the denominator, and if they all have a common factor, meaning like they can all be divided by the same number, then you should do so to continue simplifying. In this case, 6, 2, and 10 are all divisible by 2. So I'm just going to divide every one of those numbers by 2. So 6 divided by 2 is 3, negative 2 divided by 2 is negative 1, and 10 divided by 2 is 5. So this right here would be our simplified division problem with a complex number. And that's it. Not really too complicated, a lot of these steps. You're just kind of thinking about this little skill right here of an I squared turning into a negative 1. So here's another way. I'm going to kind of show you each of those steps. So first add 9 minus I squared. But remember that I squared is a negative 1. So I've got 9 minus a negative 1. If we're subtracting a negative number, that's the same as just adding a positive number. So that equals 10. So just to show you all those steps broken down. All right? Here's the other situation whenever you've got a monomial in the denominator, right? There's only one term down here, so I'm not going to multiply by the conjugate. In fact, this is super easy. This is much, much, much easier than when we had a radical in the denominator. All we have to do to cancel out any monomial with an I in the denominator, watch this, you're going to love it. It's just I over I. You're like, really, what about the 2? Well, the 2's fine. I can have a 2 in a denominator. What I can't have is an I. I can't have an imaginary number. That's the only thing I need to get rid of. And we know that if you have I and you multiply it by another I, it's going to turn into I squared, which is a negative 1. And that's fine. I can have a negative 1 in the denominator also. Just be careful with the numerator. We're going to be distributing. So I distribute this I to both terms up top. That gives us I plus 9I squared. But the denominator, that's the part that we're really excited about. 2I times I is 2I squared. But wait, there's still an I in the bottom. Well, no, there's not. That's going to cancel out, right? I squared is a negative 1. So I can just cross it out and change the sign of that term that it's connected to. Now likewise, up in the numerator, we have an I squared also. So we do need to simplify that as well. But it's going to be the same process, right? I squared, I always just cross it off and then flip the sign of the term right in front of it. So our final answer, I'm going to rewrite that numerator so the real part is first and the imaginary part is second. We're going to have a negative 9 plus I over negative 2. You can leave your answer just like that. If you do want to get rid of the double negative, you could essentially divide everything by a negative 1, which would change this to 9 minus I over 2. Some people like how that looks better. I'm fine with either way. Pretty cool, right? Last one. So look at the denominator. It's a binomial, right? There's two terms. So what do we have to multiply by? The conjugate. 1 plus 2i. 1 plus 2i. Make sure you've got parentheses around everything. Multiply this out. Let me know what you get. So go ahead and pause the video, work through this on your own, then unpause it and see how you did. Okay, here we go. In the numerator, well, that's going to be a lot of work. So I've got a binomial times a binomial, and these aren't conjugates, so I do have to do the full distribution, right? Where I've got to take 2 times each of those terms. It gives me 2 plus 4i. Then I take 3i times each of those terms. So that's plus 3i plus 6i squared. Please remember the square. I times I is I squared. Don't forget. In the bottom, that's a 1 times 1 is 1. Negative 2i times positive 2i is negative 4i squared. Yep, I squared. Okay? Now looking at every term, anytime you've got an exponent on I, you're going to want to simplify it. So this I squared changes this last term into a negative 6. In the denominator, that I squared turns the negative 4 into a positive 4. So here's what this is going to look like now. 2 plus 4i plus 3i minus 6 over 1 plus 4. And of course, there are like terms in the numerator and in the denominator that we can combine. In the numerator, I'm going to start by combining my real parts. 2 minus 6 is negative 4. Then combine the imaginary parts. 4i plus 3i equals 7i. In the denominator, well, these are both real numbers, so just add them up. 1 plus 4 is 5. And all 3 of the remaining terms, the negative 4, the 7, and the 5, don't have any common factors, meaning this is already simplified. It's our final answer. We no longer have an imaginary number in the denominator, which means that denominator is rationalized. Job well done, everyone. If you're looking for some fun, go ahead and try this evil, horrible, awful problem. I'm not going to work through the whole thing right here, but just to give you a hint, all you need to do is multiply by the conjugate. 2 plus 3i root 2. So if you're really bored today, because that lesson was short, have fun multiplying that out and let me know what you get for an answer. All right, have an awesome day, everyone. Complete your Delta Math, and I'll talk to you later. Bye.